Okay, so now we're going to look at solving equations, i.e. finding values that make the equation true. And the way in which you solve an equation depends on what type of equation that it is. So we're going to look at various types of equations and show you how to solve them. We won't show you how to be able to solve all equations because we leave that for subsequent maths classes. So the first kind of equation that we're going to look at is a linear equation. And a linear equation is one that you can write in that form there. So there's only one variable. The variable is x. A and b are just numbers. The a is not naught, so we've always got an x in there. And the important thing is this x appears by itself to the power 1. That's what makes it linear. So x only to the power of 1. In there. So I don't have x squared, I don't have x cubed, I don't have x to the 3 on 2, I don't have x to the minus 1, any of those things. That makes it a linear equation. And with a linear equation, a linear equation always has exactly one solution. There's one value of x that makes that equation true. And the way we find that equation is just by making x the subject of the equation. So let's do a simple one here. Part A. It says if x plus 6, there's my linear equation, x appears by itself to the power 1, so that makes it linear. And I solve it by making, goodness me, you can just see the answer straight away, it's 3. But to go through the process, what I would do is I'd make x the subject, so I would subtract 6 from both sides. So here I would get x plus 6 minus 6 is equal to 9 minus 6, so therefore x is equal to 3. And there is my solution. So that's a fairly easy one. And the important lesson, of course, is that you can always check your answer. Go back to the original equation and put x equal to 3 and make sure it works. 3 plus 6 is 9, yes, that's correct. So in here, can always check your answer. And the best spot to check it is right back in the original equation. And remember, our solution is the value that makes the equation true. Okay, so we've got a whole lot of these to solve. Let's do some more. In this case, I subtracted 6 from both sides. In part B, I need to divide. So let's go. If 3 times x is equal to 18, then we can see that x is equal to 18 divided by 3, which is, 6. That's better. And again, you can check your answer. 3 times 6, 18. So all I did was make x the subject. Let's do C. It says 2x minus 5 is equal to 15. 2x minus 5 equal to 15. I'm going to make x the subject. So the first thing to do is add 5 to both sides. So in here, I might just work across the page. So that will be 2x plus minus 5 plus 5, which is just 0, is equal to 15 plus 5, which is 20. Now I will divide both sides by 2. And I will have 2x divided by 2, which is just x. 15 plus 5 is 20 divided by 2, so I get 10. So I believe the solution is x is equal to 10. I go back and check it. 2 times 10 is 20, 20 minus 5 is 15. Yes, I have found the solution. So the whole time, make x the subject, isolate x, get it by itself. Let's do part D. It says 3 times 2x plus 1 is equal to 9. This equation you could do in several ways. For example, I could expand out the brackets here and get 6x plus 3 on the left-hand side. However, I think it's easier if I divide by 3 to begin with. But it doesn't matter which way you go, you'll get the same answer. So this is just one way. So I'm going to say, therefore, 2x plus 1 is equal to 9 divided by 3. I've divided both sides by 3. Let me just write here. I've divided both sides by 3. Now I'm going to subtract 1 from both sides. So I'm going to have 2x. Now 9 divided by 3 is 3, so 3 minus 1. So I've subtracted 1 from both sides. And now I divide by 2. So x is equal to 2 divided by 2, I get 1. I've divided both sides by 2. So I believe the answer is x is equal to 1. I go back and check it in the original equation. 2 times 1 is 2, plus 1 is 3, 3 times 3, 9. So it checks out, so I say, well done me. So remember, these are all linear equations because it's x to the power 1 sitting in there. A, B, C, D, E we must be up to here. E is 4 times 2x plus 1 plus 7 equal to 15. Now have a look. There's an x in here, just the one variable, and it appears to the power 1. So this is a linear equation, so I'm expecting this to have just one solution. I'm going to find that solution by making x the subject. So here I go. Let's get rid of the 7 from both sides. I'm trying to make x all by itself here on the left-hand side. So I shall say 4 lots of 2x plus 1 is equal to 15 minus 7. So subtract 7 from both sides. The next thing I'm going to do is divide by the 4. So I have 2x plus 1. Now 15 minus 7 is 8, so I've got 8 divided by 4. So I've divided both sides by 4. I now want to subtract 1 from both sides. So I now have 2x is equal to 8 divided by 4 is 2, 2 minus 1. So subtract 1 from both sides. And finally, to get x by itself, I will divide by 2. And so I'll have x is equal to 1 divided by 2. Divide both sides by 2. And so in this case, I believe my answer is a half. And again, let me check it. 2 times a half is 1. 1 plus 1 is 2. 4 2s are 8. 8 plus 7, 15. So the equation is true, and so I'm happy. And once again, let me say, how did I know which of these steps to do? Think about, if I were to substitute a value for x, I would have to multiply by 2, which is the opposite of that. I then would have to add 1, which is the opposite of that. I would then have to multiply by 4, which is the opposite of that. And lastly, I would add 7, which is the opposite of that. So if I were to substitute a value for x and calculate the left-hand side, if I do the inverse of those in the opposite order, I make x the subject. That's how I know what to do in each step, sitting here.
Is it incorrect to expand the bracket?
Nope.
That's the long way around.
It's different, not even longer.
Okay.
It's just different. Okay? Yeah.
Is there an order of reflected maths or something like that?
Yes. How do we know that? Because, remember, algebra is just arithmetic. All right? And we know that when you're doing arithmetic, the order of operations is brackets first, then indices, then division and multiplication, and then addition, subtraction. Yep. So you have to abide by that when you're doing algebra, for sure. Okay. We've still got a few to do here. So let me put this one over here. So it must be up to F. And it says 8x minus 4 is equal to 26 minus 3x. Now that doesn't look like the form ax plus b. That doesn't initially look linear. But if you look here, it's x to the power 1 and there's an x to the power 1 over here. I can combine those terms, collect like terms if you like, and then there's only going to be an x to the power 1. So this equation we would also call linear, because x to the power 1 is the only thing that appears in there. So this is still linear. So this is still a linear equation. And I expect, therefore, it to have just one solution. And I'm going to find that solution by making x the subject. And to make x the subject, the first thing to do is get all the terms involving x onto the left-hand side and all the terms not involving x onto the right-hand side. So here we go. Let's do this. So I want to put that term over this side, so I'm going to add 3x to both sides. So I'm going to have 8x minus 4 plus 3x is equal to 26. I've added 3x to both sides. I don't want the 4 over here, that's not an x term, so I'm going to add that to both sides. Now 8x plus 3x is 11x, and here I've got 26 plus 4, so I've added 4 to both sides. I want x by itself, so I'm going to divide by 11. So x is going to be 26 plus 4 is 30, 30 divided by 11. Divide both sides by 11. And there's my solution, 30 on 11. The numbers don't have to be nice. Just because it's a linear equation doesn't necessarily mean I'm going to get a nice answer. And were I brave, I could go back and check that, but I think checking it's harder than solving it. So I'm just going to think I've got it right. Okay, I'm confident. Maybe falsely so, but anyway. Okay. So what is that? That's 22 and 8/11ths or something like that. 2 and 8/11ths, I think. Okay, awful number, but that's the number that works, according to our algebra.
So just in situations like that, if it doesn't already have an equal, so just assuming when you add or minus one of your...
Hang on, go back. That is an equal sign there. If it hasn't got an equals, it's not an equation. Okay, so that's my poor writing, sorry. Yep. Okay, I'm up to G, and if we go back here, this would have solved the problem if I'd had that down there and you could have seen that it was actually an equals there, eh? So let me, I'm attempting this one now, okay? Right, good. So 3x divided by 4 plus 1 is equal to 5. Again, that's still linear, even though I've got a fraction multiplying my x here, that's still x to the power 1. So that's still a linear equation, so I'm expecting one answer, one solution, And I will find that by making x the subject. So here we go. I get all the terms involving x on the left-hand side. They're already there. I'll get the terms not involving x onto the right-hand side. So I will have 3x on 4 is equal to 5 minus 1. Subtract 1 from both sides. Now, I could do this in one go, but I'll do it in two. I don't like dividing by 4 there. I'm trying to make x the subject, so I'm going to multiply both sides by 4. And on the left-hand side, that will give me 3x. And on the right-hand side here, I will have 4 times 4. I'll say multiply both sides by 4. And finally, I'm going to divide both sides by 3. Divide both sides by 3. And I get an answer of 16 on 3, so that's 5 1/3. Again, not a nice answer, but that's what the algebra gives me. And again, I could substitute 16 on 3 in there. In fact, I can do that one. If I put 16 on 3, 3/4 times 16 on 3, the 3 cancel, the 4 go into that. That will leave me with 4. 4 plus 1 is 5. So in that case, I could actually check it. Yes?
You're going to multiply the 4 like moving the 1, will that change the answer?
If I were to multiply the 4,
Or would you have to multiply the 4 by the 1 as well?
indeed you would, because remember, this says that number is equal to that number. So if I'm going to multiply by 4, I have to multiply the whole lot by 4. Right? Yeah. And so then when I were to do this, 4 times that gives me 3x. I'd have 3x plus 4 is equal to 20. I would then subtract 4 from both sides, and I get 3x is equal to 16. And x is equal to 16 on 3. Okay? But the important thing is you've multiplied both sides. So the whole lot has been multiplied by 4. Yep.
If we change the 16 over 3 to 5 over 1/3, would that still be correct if we had put that in there?
They're exactly the same number. If I don't accept that, then I should be shot. Okay? The problem, I guess, arises in your mid-semester and final exams. It's multiple choice exam. And so it's a matter of, can you recognise those being the same? Okay? So that the answer may not be in the form you've got, but therefore you've got to be able to recognise it.
That you wouldn't also lose marks if you didn't fully simplify fractions.
So
You wouldn't lose marks if you didn't fully simplify fractions like that.
on the quizzes it says simplify where possible. So if you simplify where you can, then you are being safe, put it that way. I would imagine that if you had 32 on 6 there in the quiz, I really would, I mean, that's not the point of the exercise. The exercise, could you solve the equation? So therefore you probably get the marks, okay? Yeah. So I've now run out of paper there, so let's go over and do H. And it says 2d on 3 minus d minus 1 on 5 is equal to 3d plus 8. So have a look. D is the variable here. And it's d to the power 1, d to the power 1, and d to the power 1. So everywhere there's just d to the power 1, so that is still a linear equation. Even though it doesn't look very simple, it's still a linear equation. I could simplify it down to be ax plus b. And so I'm going to get one answer when I solve this, and the way I get that answer is by making d the subject. Now I have to admit, as soon as I see this minus sign in here, I think danger, and I would really do that. That way I'm not going to lose a minus times a minus down the track. So I don't know about you, but I prefer putting the brackets in. Okay, I would suggest it's a good technique to get used to. Okay, so I want to get d by itself, so I'm going to bring all the terms involving d over to one side, but this looks a bit awkward because of this term in here. So what I'm going to do to begin with is I want to get rid of these denominators. They're confusing me. So what I'm going to do is in this case, I'm going to multiply both sides by 15. 15 because it's 3 times 5. So I'm going to have 15, and it's times this whole lot. 2d over 3 minus d minus 1 over 5 is equal to 15 lots of 3d plus 8. I've multiplied both sides by 15. Having written that down, I can now simplify things a little bit. Because when I expand my bracket on the left here, I've got 15 times 2d divided by 3. So the 3 can go into the 15 5 times. So that's the same as 5 times 2d. That's my first term. Here, this next one, the 5 goes into the 15 3 times. That's the same as 3 times d minus 1. On the right-hand side, I've got 15 times 3 would be 45, and 8 15s would be 80, plus 40 would be 120 in there. I still quite can't get all the d's onto the left-hand side yet because I've got this set of grouping symbols here. So let me expand that out next. Then I'll be able to get all my d's onto one side. So here, this is 10d minus 3d, and then I've got minus 3 times minus 1, so that's plus 3, is equal to 45d plus 120. I'm going to do 2 steps at once now. I'm going to bring the d's over to the left-hand side, and I'm going to take the numbers over to the right-hand side. So here I've got 10d minus 3d is 7d. So I've got 7d, and I'm going to subtract 45 from both sides, 45d's. And on the right-hand side, I'm going to have 120 minus 3. So I've brought the 45d over to the left-hand side, and I've put the 3 over to the right-hand side. 7d minus 45d's will be minus 38d's. 120 minus 3 I can work out will be 117. And finally d will be minus 117 divided by 38. And that's a god-awful looking number. But if I've done my algebra correctly, that's the answer. I could, in theory, go back and check it. But once again, checking it's harder than actually solving it. But that's what I think the answer is. So as you can see, there's a lot of steps in there. To know what steps to do, I think, just takes practice in this case. Experience has taught me that multiplying by 15 as the first step was a good way to go, but there are other ways you can do things.